This is an atom of carbon, a substance found in charcoal and diamonds. Nucleus is the center or core of the atom. It is where 99.9% of an atom's weight is located. The nucleus contains protons, as seen here in red, and neutrons, seen here in green. Protons are positively charged particles, symbolized here by a plus sign. All protons are the same, no matter what type of atom they are in. The weight of subatomic particles is measured in units called atomic mass units. A proton weighs 1 atomic mass unit. There are millions and millions of protons in a single drop of water. The other subatomic particles located in the nucleus are neutrons. A neutron is a neutrally charged particle. They do not have a charge. Neutrons also have an atomic mass of about 1 atomic mass unit. While the nucleus contains most of the mass of an atom, it takes up only 1/100,000th of an atom's space, equivalent in ratio to this ball in this meadow. While all atoms have a nucleus, what is it that makes them different? The answer lies in their number of protons. The atomic number is the number of protons in an atom. For example, the element carbon, which is what makes up the graphite in this pencil, has an atomic number of 6. It has 6 protons. All atoms of carbon have the same atomic number of 6. The atomic number also equals the number of electrons. Therefore, carbon also has 6 electrons, seen here in red. Copper, a different element, has an atomic number of 20. It is useful to know the combined number of protons and neutrons in an atom. The atomic mass, also known as the atomic weight or mass number, is the sum weight of the protons and neutrons in an atom. Let's take the element silicon, symbolized by the letters Si. Silicon is a major element that makes up the sand on this beach. Silicon has 14 protons and 14 neutrons that add up to an atomic weight of 28 atomic mass units. While most types of carbon, such as that in these trees, have 6 protons, the number of neutrons may vary. Isotopes are atoms of the same element with different numbers of neutrons. For example, carbon can have an atomic mass of 12 or 14. Carbon with an atomic mass of 12, seen here with 6 red protons and 6 blue neutrons, is referred to as carbon-12. But carbon can also have an atomic mass of 14, called carbon-14, seen here with 6 red protons and 8 blue neutrons. Carbon-14 in nature is unstable and gradually deteriorates. With specialized equipment, scientists can estimate the age of objects, such as this bone, by measuring the degradation of carbon-14. Because most elements have more than one isotope, each element has an average atomic mass, calculated from the average mass of its isotopes. The fast-moving particles around the nucleus are electrons. Electrons are negatively charged particles. They are a fraction of the size of protons or neutrons. To help you visualize this size difference, if this ball were a neutron, then this P would be an electron. An electron weighs just 0.0006 atomic mass units. Because electrons weigh so little, their weight is not even considered in calculating an atom's atomic mass. Electrons move very quickly, perhaps as quickly as 1 billion times a second around the nucleus, forming what is called an electron cloud. The electron cloud is the space in which the extremely fast-moving electrons are likely to be found.